tutorial starts with a song, but it's only a few seconds long.
Computer animation. Computer animation. Computer animation.
Let's get started with animation. I want to talk about projections today. This is a torus, as you can see, and I mapped it with a grid. A grid is a flat grid. And when you go to UV and, for example, go to cylindrical, you get a different mapping. And you can change this here. We come back to this later on because I want to tell you something historical about projections. Map projection is the key word here, and for projection you can look up the Wikipedia article, which is excellent here. And here you have different types of projections of the Earth. The Earth is a sphere, and you have a map from a satellite, for example, and the satellite map, of course, is an image which is flat. So you run into problems how to apply that flat image to a round object like the Earth. So there are different kinds of projection methods, projections by surface, cylindrical, etc., hybrid, conic, and all kinds of other things. One of the most impressive projections is this one. It's called Dymaxion, and it was created, though not invented, by Chris Rywald. Thank you, Chris. It's really excellent because it shows you how you can unwrap the round projection. This is the round sphere, which is ideal, of course, and then you make a flat surface out of it, and it's not really rectangular, is it? You have the same problem with modern 360-degree photographs. I took this photograph just a couple of days ago, and of course it's a flat image. It consists of 26 images stitched together. That's why the resolution is so high. But when you go lower down here, you see everything is getting more and more warped and stretched. So this is really not the roof of a house in this kind of projection, because it's a flat image, and the further you go away, the better it looks. That's why we have tools in our world and in the Wikipedia world which allow us to see that 360-degree flat image in a proper projection, and that projection can be visualized here with the 360-degree link. And this is the German Wikipedia, so don't worry, it's the same in the English. And all of a sudden you can see the objects at the very bottom appear with proper scaling, and they're not stretched. They're exactly in the dimensions which they have. I took that with my drone from, I think, 100 meters height. So everything is intact here because it was photographed in a spherical way. It's a spherical panorama, and it needs a spherical projection, which is not ideal on a flat computer screen. You have to navigate around. And of course you find all kinds of different angles here to view, but there's not an ideal one. Because if you, for example, stay here, everything looks all right, but already here at the side, the houses get a little bit warped. So when you project a flat grid, and that was a flat grid, onto a three-dimensional object like a torus, you run into, well, a problem, or it's a challenging task in order to get this right. Let me create a plane, polygon plane, and raise the resolution and the scale a little bit, like this. And I deactivate the grid here, and I give that object a previous texture, which is a flat texture. If we have the width and height at the same value, for example 15, or 16 by 16. This looks totally rectangular and everything is fine. Now, right mouse click, go to vertices and pick a few of them. Press the key B to get the soft selection. And now press B again. Of course, the grid now looks a little bit warped, but from the top view, and this is the top view here, we need to click here in order to see it, everything still looks all right. Let's go back to object mode here and open the UV mapping menu. Let's put it to the side. When we choose camera based, let's have a look here, camera based. This is our camera view angle, and when we check camera base, we see this. Now we go back to object mode, and all of a sudden this is the projection from the camera view. It can be quite interesting, but maybe not so much. Camera based again, and that's what comes out of it. Now I think the normal based works with the faces, so let's select the faces, and we have a normal based projection now, but only in the on the faces which we selected. And now you can see that the normal is still what we had before, so it's straight lines here, whereas if you go to planar, you have this distribution here, because the plane, you can see it right here, is doing a projection from the side. And similar things work with a cylindrical projection. You see the cylinder working. We can close it more or less, or open it more or less. And the same with the spherical, which doesn't make sense very much. Flat image, which is the grid in this case, doesn't look flat anymore. From the top it looks like this now, which can be considered art, but for realistic illustration of a building, for example, this is the wall of the building, for example, it doesn't look okay, of course. So I'm not an expert in UV mapping, but what you need to do is go to UV and UV editor, or right here to the UV editor, and the UV editor basically shows you this is our grid, this is the intact grid we planted on the surface, and this is the way we project the surface in the current projection method. Sounds complicated, is complicated, and I guess when you go to unitize, everything jumps back here, and this looks interesting as well, and then you have this distribution here. And with this I leave you alone. Bye bye.